Okay guys, physics for the final section 1.1, 1.2, 1.4, 1.5, 1.9 and 1.17. Okay, so why can't we see around obstacles? So let's say we have an object here, and that it's safe to say we can assume this object is opaque because they ask why can't we see around the obstacles, and of course to see we need light. So one thing about light, it will always travel in a straight line. So let's say it moves like this. Now we know since it always travels in a straight line, it can't go around like this. It can't go around the object like that. And it's an opaque object, so that means it's not gonna bend like this. So we can say only it goes in straight lines. We can say it does not bend around an obstacle because if it goes in a straight line, how is it gonna bend? And we can say it does not go through the obstacle because we assume it's opaque. A ray of light passing through water normally strikes the plane face of separation with air. Which of the following statements are true? Okay, so I don't know if you guys remember this diagram, but this is the boundary, and then this is the normal. Now they said that the light strikes at like directly on the boundary, meaning the light strikes like this. Sorry, that's meant to be a straight line. And if it strikes directly on the boundary, it means that the light is gonna go straight through without refracting. So it's just gonna go like, sorry, that's meant to be joining. So that means it's just gonna go straight down like that. So if you remember, we take from the normal, we measure like through that like that, for example, the angle of incidence and the angle of refraction. Wait, let me draw a like a smaller one for you here so you can understand what I'm talking about. So for example so from the normal, which is the dotted line, you'd measure, this is the angle of incidence and the angle of refraction. So you'd measure like how much the angle of incidence is here from the normal to the ray of light, and the same like here. So obviously here there's nothing in the diagram I just drew, meaning that the angle of refraction and the angle of incidence is 0 because there is nothing to measure from the normal, and because it's going straight through without refracting, it's independent of the media. Underline the term that best describes what light is a form of. So obviously you can't weigh light, so you can't measure the force of light, and light is not a color, so it has to be energy. The principle of rectilinear propagation of light states that in a blank medium, this one you just have to memorize, it's in a homogeneous medium in straight lines called rays. Select the equation that best describes the second law of refraction, which relates to the angle of incidence I to the angle of refraction R. So again, this is a formula you have to have memorized. It's sine angle of incidence over sine angle of refraction equals constant. A ray of light passes from glass, refractive index 1.60, into air, refractive index 1, if the angle of incidence is 30 and the angle of refraction to the nearest integer is... Okay, so I don't know if you guys remember Snell's law. It feels like we learned it yesterday, but the formula is the first index of refraction they give you. Hold on, let me just fix my handwriting, sorry. So the first index of refraction they give you, so n1, so multiplied by sine 1 equals the second index of refraction, so n2, multiplied by sine 2. So the first index of refraction which they give us is 1.60. The first sine which they give us, so this value, is 30. The second one they give us is 1. The third one, and we need to find this. So let's just replace 1.60 multiplied by sine 30 gives 1 times sine, which is sine x, which is essentially just sine. So you put 1.60 times sine into the calculator. Sine 30, my bad, into the calculator. And you get 0.8 equals sine x. And then you take the sine. Hold on, this is very confusing. You take the sine to the other side and you make it like sine inverse brackets 0.8. So after doing sine inverse 0.8, because the goal is just to find x, they don't want sine x, they want just the angle. So when you do that, rounding it to the nearest integer, you should get 53. The ratio of the sine of the angle of incidence to that of the angle of refraction is constant. This is known as the, again guys, you need to memorize the laws of reflection and refraction. So this is the second law of refraction. A ray of light passing through the water strikes the plane face separating water from air at an angle of incidence equal to 30 degrees as shown below. What is the angle of refraction? Okay, so we're gonna use Snell's law again. So we have n1, which is just 1, so just keep it sine x, because you multiply it by 1 year, so you're gonna get the same thing. And then you get 1.33 times sine 30. And after doing it, you get that x equals, again, make sure you solve just for the x and not sine x. So you're gonna get your answer from doing this, and then you're gonna put shift sine. You should get, after rounding, 41.7. So you just do the same thing as in the last question. A ray of light passing through the water strikes normally at the plane of separation with air. Select the figure that completes the complete path of the ray. Right, so guys, if you remember in the previous question, I said that when a ray of light strikes normally at the boundary, it's gonna go straight through. So that means the angle of incidence and the angle of refraction are both gonna be 0. So that's why it's this one, because it strikes normally. What conclusion can be made? Okay, so basically if it's continuing straight, it's not deviating. Deviating is just another way. So rays striking normally at the surface of separation between two media will continue without deviation. A ray of light reaches a water-glass interface as shown below. Knowing that the refractive index of glass is greater than that of water, select the correct path of the ray inside the water segment. I was about to say if you can remember, but you are here to remember, so let me just explain. So when you're going from a less dense medium to a more dense, I'm just gonna write M for more and D for dense, more dense medium, you're gonna go towards the normal. And when you're going from a more dense to a less dense medium, you're gonna move away from the normal. So here we're going from water to glass. Now glass is more dense than water. So we're going from a less dense to a more dense medium. So that means it's going to be tilted towards the normal. That means this is going to be the answer, because out of all these options, that one's tilting most towards the normal. Which of the following are non-luminous? So what does luminous mean? Luminous means like shining or glowing or bright. So it's essentially it's emitting light. So non-luminous means the opposite. It's not emitting light. So candle flame, yes, it gives out light. It's literally fire. A window cannot give out light, because a window is a pane of glass. Like, how can a pane of glass give out light? The planet Mars. Okay, so planet Mars is not luminous, doesn't emit light. A firefly does give out light, and a laser beam does give out light. In a homogeneous medium, light propagates along directed straight lines called rays. Now, we had this question before. It's kind of like a rule, you just need to learn it. Because again, light will always travel in straight lines, and they're called rays. The diagram below shows a ray passing from air into glass. Now, if you remember in that really bad diagram I drew for you before, the angle of incidence is here and the angle of refraction is here. Now we know that the area from the normal to the boundary, so here, is perpendicular. It's always 90 degrees. And if we know this angle, which is 37, and this angle, which is 60, we can do 90 minus 37 to get this angle, and 90 minus 60 to get this angle. So 90 minus 37 is 53. 90 minus 60, sorry, you get 30. So the angle of incidence is 53 and the angle of refraction is 30. The index of refraction of the glass to one decimal place is... Okay, so again we're going to use Snell's law. So they said air was 1, so 1 times sine 53 is just sine 53 equals x times sine 30. Now we know sine, well actually if you put it into your calculator, we know sine 30 is 1 over 2. Sine 53 equals x times 1 over 2. And you get, just put sine 53 alone into your calculator and just put that divided by 1 over 2. Because of course it's going to go to the side. And you get x, which is after rounding 1.6. There exist two types of light sources. So the first one's artificial, because if it's man-made, it's fake. So, and natural light source, which means the Earth just made it itself, so it's natural. An artificial light source is... Okay, candles is artificial because the wax didn't even come from the Earth. It's literally man-made. The sun is natural. It's been there forever. Oil lamps, again, that did not come from the Earth. Lightning, yes, it's natural. Fill in the blanks using the correct terms from the box below. A blank body radiates visible light by transforming different forms of energy into visible light. Okay, so it radiates light, so it's luminous. A blank body allows light to pass through, but it is not possible to recognize the objects seen through it. So you can kind of see it, but it's blurry, so it's translucent. An object is said to be blank if it does not allow any light to pass through. So opaque, because there's literally no light going through. An object is said to be blank if it allows light to pass through it, making it possible to see objects placed behind it. It's transparent because all the light going through, you can see it all. A blank body merely changes the direction of light falling on it from luminous ones. So non-luminous. Okay, this one's kind of obvious whether you can see through it or not. So you cannot see it through a block of iron. Now a thin layer of gold is transparent. Air is transparent, of course. Wood is opaque and olive oil is translucent. The diagram below shows how light strikes a curved mirror. The light rays propagate from point A to point B. Between point A and the mirror, the beam of light... Okay, so between point A and the mirror, so we're starting from A, moving to the mirror, we can see it's going apart, so it's diverging. Now between the mirror and point B, so we're starting from the mirror and we're going to point B over here, we can see it's meeting at one point, so it's convergence. Okay, match each term to its definition. Okay. The angle that the reflected ray makes with the normal at the point of incidence. Again, I showed you a diagram of this, but reflection, reflected ray makes sense. The same thing with incidence. The angle of incidence is the angle formed between the incident ray and the, of course, normal. at the point of incidence. This is literally what I've been saying for the past 15 minutes. The laws of reflection are used to study the transfer of light between two media. The first law of refraction states that the incident ray, the refracted ray, and the normal at the point of incidence all lie on the same in the same plane. What is this plane called? And I can't really explain this one to you, you just have to learn it. Plane of incidence. What does the second law of reflection state about the ratio of sine of the angle to the angle of incidence to that of the angle of refraction? They're basically saying the formula is sine angle of incidence over sine angle of refraction is equal to constant. So if bodies radiate visible light, then they are said to be luminous. Like I said before, these bodies are other sources that transform other forms of energy into visible light. This one's kind of obvious. Bodies that merely change the direction of light falling on them from other sources of light are non-luminous. Again, I've been saying this. It is possible to choose a thin enough sample of any material to obtain a transparent sample like the gold, like the block of gold. If it's thin enough, it becomes transparent. A stack of 100 panes of glass is almost transparent. I mean opaque, sorry. Because if you stack anything like that much, of course it's going to be opaque. Which statements are true about light rays? Okay, so light rays are actually not real. They're imaginary because like every single day when you look at like any form of light, you don't actually see lines. Of course you don't. Like you're looking at light right now and there's no lines. But when they're represented, they are represented by straight lines with arrows. It's not straight line segments because they're not segments. And this whole imaginary straight line with arrow thing, it's just to show how the energy is moving, so the direction of energy propagation. Parallel beam, okay. Match each type of beam to its definition. So a parallel beam moves like this, hold up. It moves straight like that. A divergent beam moves like that, so it's basically parting ways, it's diverging. And a converging beam meets at one point, like that. So a parallel beam would be a collection of rays propagating in the same direction. Diverging would be a collection of rays that come from one point, and converging would be a collection of rays that meet at one point. Okay. The thin parallel beam produced by a ray box can be used to represent a... Again, this is from the verifying the laws of refraction. So, of course, the beam produced by ray box can be used to represent... Hold on. Okay, guys, it's so important you memorize the diagram for this question. So, let's start explaining this. So, as we said before, that this part is the boundary. It's separating the bottom part from the top part, whatever you want to call it. It's just separation, so it's the boundary. So, let's just put B here. Now here, these arrows are pointing to this area and this area. I also said this before, the area between the first ray that strikes, which is the incident ray, and the ray that's copying the incident ray, which is the refracted ray. So the angle between the normal and the incident ray is called the angle of incidence. And the ray between the normal and the reflected ray is called the angle of reflection. So that means that this point where it all meets essentially, this is a point where all meets, is called the point of incidence. And yeah, that's basically what you need to know for this diagram. This question's easy, you just have to know it. Medium of refraction is a space where light travels after it strikes the surface of separation between two media. I like to remember this by medium, so like medium space, they kind of correlate with each other. Angle of refraction, the angle that a refracted ray makes with the normal. I explained this, and the path followed by an incident ray after entering a new medium. Refracted ray. The diagram below shows a ray of light incident from air striking the surface of separation air, water, and what do I keep on studying? Okay, refracting inside the water tank. The ray reflects at the bottom of the tank and emerges out of the water tank, making an angle A with the normal. Wait, I think that's alpha. Okay, so we can see that this is the incident ray. Okay, but that is a really bad color choice, so this is the incident ray. We can see that it makes an angle of 40 over here and 45 over here. Now this is the reflected ray, and it makes also angle 45. Now, of course, if it's reflected, it's gonna be the same thing. You know, like, you see reflection, it looks the same as you do. Do you know what I mean? Do you know what I'm getting at? So alpha is gonna be 40 because it's reflection, it's reflecting. It's the same reason why 45, hold on. It's the same reason that 45 and 45 are the same, because this ray and this ray are both reflecting from each other. So it's 40. Again, see, this diagram is super important. I explained it already, so I'm not going to explain it again. Okay, translucent is when objects can kind of pass through them. Like, it's blurry, but you can just make up the outline, so you can partially, like, the light partially goes through. Opaque, now you can't see anything through opaque objects, so transparent, that allows light to pass through them because you can see through a pane of glass.